Hi everyone, my name is Patrick Edelman and I'm presenting CMVE, a framework for multimodal video editing. This is a collaborative work done between Fovea, Columbia University, and the City University of New York. Automated video editing from text is an emerging problem posed by increasing amount of user-generated content and advancements in multimodal learning. It first requires understanding of video through extracting key events, characters, and objects. Next, it requires segmenting videos into clips, which is typically done through dense captioning or clustering to allow for video retrieval. Lastly, it requires modeling creative decision-making by video creators who use editing software to compose a new video from individual clips given some text query. Recent methods have addressed these problems by improving aspects of the editing pipeline, the quality of search, video metadata extraction, or interface design to automate editing workflows. On the other hand, researchers have focused on synthesizing video segments from text, but these are often short clips in controlled settings or require large amounts of raw footage. CMVE is the first pipeline for automated editing where the goal is driven by a storyline of the output video and is flexible enough to edit long-form video. Our approach attempts to create a video given an input query, a database of existing videos with descriptions, and at least one reference sample used to weigh similarity between objects, known entities, and perceptual metrics. Specifically, we score the database of videos by text embedding similarity using the universal sentence encoder with the input query. Next, we utilize a clip segmentation model to process single camera shots from this database in order to synthesize a new video. For each clip, we capture a representative thumbnail and detect recognizable figures, bounded objects, and unbounded concepts. Professional video editors often use reference video to guide their video editing decisions. So to mimic that, CMVE learns a style vector from a reference video. CMVE places an importance on the retrieval of the first clip of the output video. This clip is then used to dictate the selection of subsequent clips, which are ranked based on the reference score vector describing the similarity to the reference clip. CMVE calculates the overlap between the input text description and within video similarity measures. We learned from a single reference sample by calculating the perceptual similarity of composing shots by mapping VGG feature activations to perceived similarity of thumbnails. Next, we calculate the average cosine similarity between objects and concepts in the clips using standard object recognition models. Lastly, we relate the reference sample video to the reference input query by weighing the part-of-speech dependency tags of recognized entities. In this way, we learn a single vector weighing the perceptual, object, and concept similarity of clips in the reference sample, along with an entity weight vector that describes how clips weigh recognizable entities in the editing style. During video editing, we synthesize a video compilation for each sentence of the input text query and concatenate clips into a coherent video. We retrieve the first clip based on description similarity distance and entity overlap score. Next, we score the remaining clips in the database using the learned score vector representing perceptual, object, and entity similarity. We applied CMVE on a news compilation video dataset. We chose a variety of news topics from 2020 relevant to the US news market and selected a total of 12 input storylines used to edit short compilation videos. Each video was also edited by a professional, which we used as the ground truth in assessing the quality of CMVE edits and as a reference sample. We arrived at the following learned entity and similarity weights, which indicates that the editing style of reference samples depended on known entities being the subject of clips, and a relatively larger weight on object similarity over perceptual similarity for news editing. We recruited 80 study participants who rated the quality of professional and CMVE edits across all topics. CMVE shows competitive performance with professional edits, with less than 5% rating difference on average across topics. We found performance to be topic-specific, but found no effect of entity presence on the video quality. We provide pseudocode of our implementation along with an online demo of CMVE. On our demo page, you're able to view the professional edit side by side with the CMVE edit.